today with
Oh,
our
okay.
this
Yeah.
thing.
Okay. Yeah.
Yesterday, so unfortunately, we had a power break at the last minute of our class. I think we are almost done with the time as well yesterday, but still there is a sudden power cut yesterday. So let me just share my screen. We were talking about this actually. So what is that? Concurrency and parallelism. That is something, and we were uh, discussing about concurrency. That is a simple example we had discussed, and we just tested that scenario. This is the example we did yesterday. Uh, Let me just show you. I think there is a slight latency today. Yeah, this we did yesterday, concurrent test, and you can also see that. And we had a clear discussion with the diagram as well about concurrency yesterday. So I think this is the one something we had discussed just definitely. Next after that, the next topic is what is that? Parallelism. Even this theoretical discussion we did completed yesterday. Parallelism is simple, right? We took a simple example to understand. Suppose if we have a restaurant, each chef preparing a separate dish so that we can increase the speed. We can increase the speed of cooking. Similarly, here in programming, we can increase the speed of execution of some specific task. And how do we achieve parallelism? Simple. And what is the exact technicality behind parallelism is simple. When you are working on parallelism, this is something maybe this should fit your requirement. Uh, sure, sir. We will check on that. Still, we will check on explore on this scenario. So
Sure.
parallelism is used when a computer has multiple cores or processors, and we had discussed this yesterday. Generally, this is very much useful, right? It splits big tasks into smaller tasks and run them all at a time on different cores. And this makes program much faster than concurrency, especially for tasks like big calculations or data processing. Got it right, friends? Then application wise, this is simple. How to implement this means we have this. There is a built-in class here process. To this process, what do? We try to pass it, like everything is same like thread constructor or thread object. Only difference is instead of thread, we use process here to use this parallelism, right? And even the program, everything is same here. The task thing, what we did yesterday. This is a very simple program. When you look at this, there is nothing. Just we had a print that it started, that it is completed. Meanwhile, one sleep method. That's all. And that we are passing as a target to this process object. And we are also passing arguments to keep track of how many threads are created or how many processes are created. And for that, we are passing I as a parameter. And we are iterating this loop for 5 times where we create 5 processes in this program. And at the same time, we are trying to just add this process to a list just to apply join on this process. When you apply join, your main method will be kept in waiting so that the other threads will keep executing. That is what the idea of this block is. And I had clearly explained yesterday about the join scenario. Now, what do? We just try to run this. And if you remember the output of this is a regular concurrency execution. If it is processed, definitely there is a kind of a parallelism involved. At the same time, output wise also, we should see some kind of order here. So what do? Is I'll just create a new file here. Uh, my machine is a bit slow today. I should probably I should clean up my C drive. We'll do that after class. And a new Python file parallel underscore test. Okay. And then just take this test this code. That would be enough for us, friends. Whatever we have here, please test this. This is a simple example to understand this parallelism. Okay, so that it's easy for you to follow. Still, the file is getting created. Let's just give a minute. Yeah, it should be fine now. So now what do we do? Still creating. Yeah. So this, let me try to test this code block. Hmm, it's taking time. Okay. So let's see this now. Right. Let's run this now. Right. Hmm. Yeah. We are executing this program, and for that we are using parallel. There is actually a process method here. You can see here. Hmm. So yeah. Now this is the, yeah, you can see here now. So how many processes we are creating here? We are creating 5 processes. You can see task 0, task 4, task 0, task 1, task 2. These are the 5 processes we are creating. And task 3 completed, task 0, task 1, task 4. Yeah. So this is parallel processing. So what's happening here? Instead of concurrency, we are approaching parallel processing. Difference is there will, this executes a bit faster than concurrency. Concurrency might be having a kind of delay, but parallel processing might have much more better execution speed. Why? Because each process run in its own core, so that this is much more faster approach than that. And you can see here, I think output wise, yeah, output wise, we are not seeing big difference because you can see here task 3 started. Of course, we created how many processes here? 5 process, task 0 to task 4. So when you create process and start creating that, we are calling start on that each process. So that among those 5 process, first task 3 started, then task 4, task 0, task 1, task 2. Then task 3 completed first, and then task 0 completed, and then task 1, task 4, task 2. Okay. This order wise, I think it's not exactly following. Maybe we have to use that synchronization. That anyhow we apply that. But scenario, with this scenario, the advantage is, what is the advantage, friends? We can achieve that execution speed with parallelism. That is exactly what it is. So if you ask me how that differs, this differs from concurrency. The concept of concurrency is one CPU switches between multiple tasks. And in parallelism, what happens? We have multiple cores, and that for each process there will be a separate core, or separate what shall we say, separate stack involved for executing that. Definitely, you can see here this clearly. I just put this statement here. You can see here. This is especially used for what? This is much faster than concurrency, used for big calculations or data processing. So that is the idea. So finally, based on this, you can choose this. You can see when to use parallelism. Right? If you have a multi-core processor, that is one thing. Definitely, when you are working on applications, your hardware has multi-core processors. Definitely, is when you are working using your real-time systems, they will definitely have multi-core processors. Generally, this is very much used for big data processing or data engineering, AI, and simulations. When tasks don't depend on each other and run independently, in such cases, we apply parallelism. If they are dependent one another, then we have to go with thread synchronization. Got it, right? Then these are key differences between concurrency and parallelism. This should give you a clear idea, like which one you should apply, right? So how this works here, you can see now. In concurrency, CPU switch between tasks. And here in parallelism, run tasks at a time. All tasks are executed at a time, and every task has its own stack so that execution speed will be more. And here CPU requirement works on single core, and we have multi cores, and each core will execute one task in parallelism. But in concurrency, one core will be switching between all tasks. And best example to get a quick idea for concurrency, one chef cooking multiple dishes alone, switching between them. For parallelism, multiple chefs cooking multiple dishes at a time. So you can understand with this example clearly. So finally, this is the idea of parallelism and concurrency and how to achieve that. Generally, for concurrency, we can use regular threading, but for parallelism, you can apply this multi-processing that process. So it's up to you which one you choose that. Okay. Now, finally, let's get to the another topic, thread synchronization. This is also something really important. In some cases of programming where you need proper execution order, where you want data consistency. So generally, if you look at this output, then by looking at this output, we cannot 100% say this is a consistent output. Yeah, definitely we have 5 tasks, they're starting and they're executing. But the order changes. We cannot predict the output here because all these threads are in our process are in a race condition. What is race condition? Multiple threads try to acquire CPU or try to get the attention of CPU, and we don't know which thread might get a chance. That we cannot predict as a developer. It's the thread scheduler which decides that. So in general threading or in regular thread execution, we cannot predict the execution of threads because it depends on thread scheduler. To control this execution, we have a we have something for developer. What is that? Synchronization. Of course, this is not 100% recommended every time, but in case if you want to control that that execution flow, that order, then definitely if you want to bring in that consistency, data consistency, then synchronization is the best example. You get an idea, much more better scenario in this synchronization so that you get a clear picture where we miss in a regular threading, how we miss out on that data consistency. Got it right? How we miss data consistency, and with synchronization, how we achieve data consistency, and when should we apply synchronization in the code. This discussion definitely gives you a detailed analysis on that. Okay. So thread synchronization means simple. When we have multiple threads accessing shared resources, right? To prevent race conditions, race conditions in sense unexpected behavior of multiple threads modifying shared data at same time. So this is race condition. And this is real. This is something we have issue with databases. Suppose if you take the example, so let me take a new one. So you have a database. Let me just show you. You have a DB. Okay, this assume that this is your database. Okay, there is some table in the database. So that table might be, you can put it as an employee. Okay, this is an employee table. Okay. Now this employee has some data. Now we have multiple threads here, right? I have, so what is that? I have different tasks and threads working on this database. Assume that each block here is one thread. Now, all these threads, this is thread 1, this is thread 2. So when should we choose synchronization? Definitely in these kind of scenarios, synchronization is especially while working with database, reading data, writing data. When you do that database writes or reads, especially writes should be much more synchronized. Okay, because we should have synchronized writing into databases, else it might leads to data inconsistency issue. Got it right? So this is T3, again this is T4. So if you are using just threads like that, these are in race condition, right? All these threads will go and try to modify this data. Suppose you are doing a write operation on database. What is that you are doing? You are doing a write operation on a database with threads. Now, no control. You are following a regular threading approach. And what is the problem with threads? Race condition. What is that? Race condition. I had explained this even yesterday and day before yesterday also. Race condition means each thread try to execute parallelly. Every thread will compete for the processor, right? So in that process, we cannot predict which thread will get chance to execute on this table in database, which may not. Suppose you are using unsynchronized approach, not a synchronized execution. Synchronized means following a proper order in a queue. If you are for using unsynchronized approach, this table might be updated improperly, right? One will be updating half, the other will be updating something else like that. This might leads to a data inconsistency situation. To avoid this, we have to always this in these kind of scenarios, synchronization is the best thing. Okay, got it right, friends. How you do that? We'll see a practical example now. How this data inconsistency arises and how we can fix that with synchronization. This is a very beautiful example. So when you are doing these database writes, when each thread try to do this write operation, and there might be a problem of data write issue or data inconsistency issue. So in such cases, what is that you have to apply? Always you have to choose synchronization. Some in a real programming, this we apply, but with some caution, because synchronization is not something really recommended always, right? And how do we achieve synchronization? By using a lock scenario. There is something like synchronization always involves a locking scenario. What is this locking? We use thread.lock thing to ensure only one thread modifies a shared resource. Meanwhile, the other threads will be waiting. Got it right? So this is the solution of synchronization. What is that? When you have a race condition among threads, to control this race condition and put threads into a proper execution order, so we apply a lock concept. And in threading, we have a built-in lock class, which is lock, to ensure only one thread modifies a shared resource. Got it right? This is the idea. So now, what do we do when you apply synchronization? Here, not all threads will go and try to modify the table in database. First, if T1 is acquire, there is a lock concept. Now you put a lock scenario here. Okay. Now, if T1 acquires lock on this table, then T2 has to wait there, T3 has to wait there, T4 has to wait there. They cannot go and try to access this table. When T1 is executing, remaining has to just wait. Once T2 releases lock and give it to some T2 or T3, T4, then one of these again might get a lock first. They has to again get a lock. Okay. Then they has to go and go execute this table. And this locking is something which controls the execution of threads and avoid race condition. You got it right, friends. Sir. So how do we? The point is Here the question is, how do we acquire lock? How do we release lock is the question. So for that, how to apply this locking system inside in threading, there is a lock concept. Got it, right? And in this lock class, there are two methods. One is acquire lock, another one is release lock. Simple, right? So that's what we are going to do. And here, to achieve data consistency, we apply this. And how do we apply this? When multiple threads are executing, only one thread is allowed to execute. Meanwhile, remaining has to wait. Synchronization involves a lock concept. Okay. The thread which acquires lock keep executing. Meanwhile, other threads has to wait until the current thread releases the lock. Got it right, friends? That's the idea. Example, let us take a simple example, bank account balance update. Here, what is happening? Multiple threads try to withdraw money for the same bank account, shared resource. Without synchronization, balance could become incorrect. We are taking that example now. This is the example. Okay, let's try this now. So this is withdraw method, and we have a balance of 100 here. Same thing, even you can try with database as well. It's fine. Now, what is happening here? So now you are just declaring this as a global variable, balance as global. When you say global space balance, making this as a global. And remaining things are simple, friends. There is nothing difficult in this code again. What is that we are doing? We are trying just getting the current thread name that is trying to execute this withdraw method. Okay, and then you can see here, this is without synchronization. For FYI, this is without synchronization. So we see that data inconsistency issue here. So if balance greater than amount, then you should do the withdrawal. That's what you should do. And you should check that you should update that balance, balance equal to balance minus amount. So that says that we did a withdrawal. And finally, what is that here? We just specify that amount we withdraw and remaining balance. Both we specify this. We did also do a similar example sometime back as well, right? For exception handling. Now, finally, what is that you should do? This is the idea. If balance is sufficient, then you do the withdrawal, and that should go fine here. That should go well here. Else, if balance is not there, you just may specify not enough balance. That's what the scenario is. Now, what you are doing, this is the logic part here. Just doing a simple balance check and then doing a withdrawal. And finally, what is that? Updating that amount withdraw and remaining balance. It's a very simple program, right? If you don't have sufficient balance, then you are just specifying that you don't have balance. Fine. Now, what is that you are doing at thread level? You are creating 3 threads, you can see, and we created 3 threads. And for the target, we are passing this balance method, that is withdraw money. And args, we are passing this. This is amount to withdraw. 50 is nothing but amount to withdraw. Okay. And this is the name of the thread. You got it right. User hyphen I plus 1 means just providing name of threads. And we are creating 3 threads here. Just using a thread list here, and we append all that thread objects to the list to apply a join here. So that main method will keep waiting until the remaining threads completes the execution. Okay, this is the idea. And you call start on each thread so that they just try to do withdraw. This is the idea of the logic code. So let's test this now and see what would be the what is that we are missing here. So when this withdraw should happen only if balance greater than amount. Else it should say not enough balance. Let us see how this is going to create a data inconsistency issue. What is that? So you can create a new file here. So data inconsistency. Okay, .py. And this program definitely leads to data inconsistency because when multiple threads try to operate on this method, we didn't apply any synchronization here. This leads to definitely a data inconsistency issue. Plus, let's try to run this now. That gives you an idea, right? See here, user one is trying to withdraw 50. See, three threads are trying to withdraw at the same time. So first thread can withdraw 50 rupees, no problem. Second thread can withdraw 50 rupees, no problem. Third thread is trying to withdraw 50. We just have 100 rupees. Where do we have another 50? Possible, friends? We just have 100 rupees. We don't have 150 here. And user 2 has withdrawn 50. Remaining balance is 55. And the other thread, user 1 is trying to withdraw 50. Remaining balance is 0. See. And now user 3 is trying to withdraw 50. Remaining balance is minus 50. Does it make any sense here? You got this right. What is this minus 50? Already when it becomes 0, you are trying to do another withdraw 50 and it is showing minus 50. Is it possible? Can you have a balance, negative balance in your account and you can do a withdraw with 0 rupees in the account? So this is where we are leading to a data inconsistency issue. These threads, what they did is, while trying to be in race condition, somehow it is this is not able to work efficiently, this block. Then we have to control this block. We should not allow all threads to go and fall on this. We should just give a controlled access to each of these threads, three threads. And final balance is minus 50. How come this is possible? Right. This is where the data inconsistency issue is coming. So how do you control this? How do you fix this situation? That is where we have to apply. What is that here? This log scenario. And why this issue is coming? Multiple users might withdraw simultaneously, causing incorrect balance updates because of race condition. And for that, we are bringing in locking scenario. And what this lock will do? We are applying a lock with lock like, right? With files we applied with open. Similarly, we can apply with lock, right? So when you apply with lock, automatically this is in a controlled this thing. Got it right, friends? So this is the idea. And when you apply with lock and all that code, you can just keep under that with lock. Then lock is applied. And this ensures only one thread modifies balance at a time. And this is what synchronization is. Of course, you can also use acquire and release methods, but for now, you can go with this approach also. Finally, just this particular block, wherever that locking is needed, not on the entire code. You have to apply locks carefully, right? Locks are applied only on the code blocks where that synchronization is needed. If you put on everything, then the problem is what, friends? Then this will leads to waiting stage. And that if waiting state increases, then again it might lead to deadlocks, starvation. There are certain things in threading. Again, the threads is not always something really good to use, because there are times where threads are disadvantage as well. We'll talk about that. Okay. So, but this is the idea. Same thing. Just only thing is to the same code. We are just applying lock. Under that lock, we are keeping our code so that we ensures this synchronization is applied. Now, what do you do? Just take this same method. We do which only that is the change. Other than that, everything is same. Now you come here, apply this new Python file, synchronize text. Okay, put it here. This time you run this, definitely you see some difference in the output. You don't see that data inconsistency issue this time. You see this. Yeah, three threads try to acquire. Now you see this user 3 is saying, hey, I don't have enough balance, no enough balance. But in the previous execution, you saw that balance is minus 50. If such kind of practice is there in banking, then definitely anybody can have money without money in the account. Okay. Why? Because there is a flaw in your software. Now you fix that by applying lock here, and that lock again you have to choose that. You have to apply only on that particular block where lock is needed. Otherwise, this lock is very dangerous. This locks can lead to deadlocks or starvation. Got it right, friends? So this is the idea. So I think I have to share three code. One is parallel test today, whatever we have discussed. Let me share these programs. Interesting, right?
Can we use like
Threading.
multiple locks, sir? I mean, on the same program. Let's say I
Uh,
have update statement, I have insert statement. Both I
yes,
wanted to
sir.
control actually.
Yeah, when you have multiple, if both are in under same block, one lock is enough, Shiva sir.
Okay.
Suppose if you have two different code blocks, then you have to choose separate block for both code. If you have two different methods, suppose you see here, sir, we have withdraw money. You are saying deposit money method is there. Then you need a lock on deposit money and you need lock inside withdraw money, something like that, sir.
Oh,
Did I
okay.
answer the
Yeah.
question, sir?
Yeah.
Okay.
So you can have any number of locks within a code, within the function or within the code.
Yes, sir.
Okay.
But when you have, I mean, when that code block is different, if it is same block, one lock is enough, right, sir? When you say
Uh,
lock,
yeah.
right, under that, if you have that, if that code is within the same method and if under the same thing, same block, then one lock is enough. Because once if you acquire one lock, all that code is under locking scenario, sir.
Okay.
You got
Yeah.
that thing, right, sir?
Yeah.
If suppose if they are in two different methods, then you have to choose two different locks. One for that particular calculation under withdraw, one for under deposit, one for under balance check, something like that, Shiva sir. Is that clear?
Okay. Yeah.
Yes, sir.
But all
So
threads will start parallelly, right? Only while writing, while
yeah,
executing this
all
code
these
block.
threads, yes, sir. Only in the it will get the synchronization is applied only for this block of code, sir. Remaining
Mm,
things will execute as usual. That parallel thing will be keep going on.
Okay.
So that is why we have also mentioned the caution. The caution is what, sir? Locking is okay, is something really useful, but at the same time, locking is dangerous as well. Why it is dangerous? If you put lock for the entire code, then again that is stopping the execution of other threads as well, sir.
Yes. Correct.
So very important point about locking is you have to be careful with locking. So you have to choose only that particular block where your actual operation is involved. Remaining things you can leave it as is, sir. Okay. So sharing this code with all of you. So let me just share this code. Next after that, I think I shared other this thing right yesterday, Shiva sir.
Sorry, sir. What was the question?
Yesterday I shared all other remaining programs, right, sir?
Yeah.
Okay. Let me just share this too. So we have parallel and then data inconsistency example. And then one more is synchronized example. Okay, these are all the programs we did so far on this. I think we are almost done with majority of that. There is one more topic here that this is about what is that, friends? About synchronization. Next, another example is we are done with synchronization probably. So how lock works here? So with lock is something ensures only one thread can modify the balance at a time. Other thread must wait until lock is released. And this prevents race condition, ensuring correct final balance. Got it right, friends? This is very clear. and very simple to understand. And when to use thread synchronization? When multiple threads try to modify shared data. If you look at this example also, this table is a shared data for all these threads. And if each thread try to go and modify table without looking for synchronization, then there might be definitely a data inconsistency. When thread T1 is trying to modify something, at the same time, T2 might read that data. Without T1 completing the right operation, if T2 reads that data, then what's happening in the subsequent operation, there might be a problem. You might miss on that proper update. So that is why in these kind of scenarios, we need synchronization. So that avoids what? Data corruption, data integrity issues. To ensure correctness in multi-threaded programs, we need this thread synchronization. That's all about this one, friends. You got it right. So finally, this is the foundation for threading. All this will definitely give you a strong foundation. Now, finally, one more example, thread pool executor. One of your, right, Roman, I think this is what you have asked in, about a couple of days back. Yeah. So this is simple. Again, what is this thread pool executor? Right? This is a more efficient way of managing threads, simply speaking. Suppose in this example, you see this example is enough to talk about that. You are creating 3 threads. Sorry, friends. Okay. You see in this example, you are creating 3 threads. Okay. 3 thread objects. And then this cleaning of these threads and all this calling starts, everything. So you have to do it explicitly on each thread. Right. So this is more like doing a manually. We create everything and we try to start everything, and finally internally garbage collector will do the cleanup process. All that. When you are having thread pool executor, what is a thread pool executor? Here, simple. Pool means we can create multiple or some group of threads together. That is what we call pool here, friends. Okay. So the advantage is when you create this thread pool executor, all this creation of threads, managing synchronization, and applying cleanup, thread cleanup, all that is automatically done here. Okay. So what is a thread pool executor? First, let's go one by one. So concurrent on features dot thread. This is the uh, class that exists inside this module. And it is a high-level API for managing multiple threads efficiently without manually handling thread creation and synchronization. So in this example, you are doing everything. You are applying synchronization, you are creating threads, and you are starting threads, and you are releasing threads. So all that is automatically managed by the thread pool executor. So what it does here, this is very clearly specified here. When you create threads manually, what is that we should do? We should start each thread. Yes, right. That's what we do. We start thread manually. And then what is that we do? We manage synchronization. That is true, right? Here in this code, we applied lock. So we are managing synchronization. Third thing, handle thread cleanup manually. Right? This finally, internally, what happens? This cleaning is done. That means once this thread execution over, that objects are automatically garbage collected. Of course, we have automatic garbage collection which do the cleanup, not a problem. So that go one by one there. And that is even handled by the thread pool executor. So what thread pool executor does here, it automates all of this without you doing anything manually. How? This is curious, right? This looks curious. Yes, right. If you don't do that, how thread pool is doing all that? Let's see that. Why use thread pool executor? Easier than threading dot thread, this one. Easier than this approach. Of course, it's up to you which one to choose. But once you understand the concept, you decide which to apply. Automatically manages thread creation and execution. Efficient for IO bound task, input output. Okay, like for example, some database reads, file reads, API calls. You know, right? APIs. While doing API calls as well, this thread pool executor is something really useful. And even to do this database reads and writes, thread pool is something an efficient approach. And for to use this thread pool class, we have to import this package concurrent.futures. All right. And this example is very simple to understand. Again, task is same, the same task which we are using here, sometime back at the top. Same similar task only. You can see that. So nothing is there in this task. If you look at it, this is only just a simple method just to show the behavior of threads. That's all. Under that, we just say that thread started, thread completed. And one thing we do is we return the result of that task. We can also, when you are using this thread pool executor, you can return the result of that task as well. And in between, you just apply sleep. Okay. So this result can be anything you want to return in your actual method. Okay, that is fine. So this is the idea. Next up that, what is that you are doing? You have a driver program main here. Under that, we are creating thread pool executor, and you are clearly, you can see here, we have actually a parameter max workers. How many threads you want to create, or how many you can create a pool of threads here that you can limit here. That limit you can specify here while creating this thread pool executor object itself. Got it, right? How many you want to create? Three threads, 5 threads, 10 threads, 20 threads? How many you want to create? So that you have to specify here. Number of worker threads you want to create. So means what? It's like creating pool of threads at a time, and these threads will be efficiently managed internally among all threads. Okay, for the task you are doing, you should just figure out how many threads are needed. Based on that, you have to allocate those threads. This is much more efficient way of creating pool of threads. So that is what thread pool executor do, and just you need to pass that what is Vishay, that that parameter. How many? What should be the limit? That is important. Then after that, what is that? You can see here. Once this is done, this is more like opening a file. And here is the file parameter. We use executor object here. That's all. Generally, we have file object here because this is a thread object. So we create number of threads we want here and then just specify that object. Under this code, we apply this results. Results is okay, fine. But we just call executor.submit. This submit method is more like more or less calling your this thing. Like this is submit is more like this. You can see here what you are doing. You are calling target, right? To that target, you are assigning task, right? So here instead of direct, so what is that we are doing? We are passing this target to the constructor. But here what we are doing, we are just calling submit method on this executor. Right? This submit takes, what is that it is taking? It is taking two parameters. One is that method you want to call on a thread, and the parameter you want to pass to that method, that you have to pass side by side. And we are executing this. This is actually a list comprehension. Okay. And you can simplify this. If you think this is a bit confusing to you, you can make it much more simpler. Okay. So, so this is the idea. Got it right, friends? So what is that? You are iterating a loop for 5 times. Every time loop iterates, you are executing this submit method. This submit is something which will try to invoke a thread on these thread methods. Okay, task and that parameter. Right. This is the what happens. This code block is doing. Right. Is here you are not creating any thread objects here. You can see you just specified number of worker threads, that creating threads and then starting threads and then again cleaning threads. Everything is done by the thread pool executor. This is simple. Just you specify number of worker threads and then just call submit method to submit method. To that you just pass that method name and then parameter. And how many threads you want to create? I created 3 threads here. Sorry, 5 threads here. But even though we have 5 threads, so at a time, how many threads can get the CPU? At a time, 3 threads will get the CPU. Then after that, remaining 2 will get the CPU. Once after first 3 threads, whichever get that CPU, once they get executed, then only remaining 2 threads will again get the CPU there. We'll see that while executing. And finally, this method, this submit, once it completes execution, it will return that results, and all that results are stored in this as a list. Right? You can see this task is returning result here. That results are stored here. Once the execution of each thread is successful, that will return something from the task, and that is assigned to the results. Okay, finally now collecting results as they complete. As this thread is executing and returning results, parallelly what you can do, you can also just run that results by calling that future.result. Got it now? So there is we can use this, right? Future, that future is nothing but dummy variable. And you can see this method, what it is saying, concurrent future, this module has as completed method. To that you are passing this results parameter, right? As these results keep on completing, and we can fetch that results back here and see that output. Okay, you understand this better when I run this now. What do? You just copy this. Okay, this gives you an idea. How many threads we are creating? 5 threads. Let's do this now. Let's do one thing. Let's apply this here. What is this? This is nothing but thread pool executor. Now run this. Now you can see 3 threads started here. This gives you very clear picture, right? So when task 0, task 1, task 2. How many threads are there in the code? We have 5 threads. You can see we are creating 5 threads and submitting those tasks on these threads. Fine. Now when you submit, but how many worker threads are allowed here? 3. No matter what, you have 10 threads. But at a time, we execute a group of threads as a pool. Now task 0, task 1, task 2 started executing. Then you can see task 0 completed. And then after that, it picked up task 3. Got it, right? And results of task 0. Again, task 2 completed. While these were completing, then only the other thread is giving opportunity. Means at a time, at any given time, this thread, sorry friends, this thread pool executor can allow 3 threads, max 3 threads executing, right? And you can see that once that another thread completes, then another waiting thread got a chance here. Task 2 completed, then task 4 started. And result of task 2 is written here. Again, task 1 completed. Result of task 1, task 3 and task 4 completed. We get those results as well. So if you see here, if you observe the execution flow, definitely there is a level of synchronization here. Once 3 threads get a chance, remaining 2 should wait. Once task 0 completed, then only it gave chance to another waiting thread. So that at a given time, max 3 threads are in the thread pool running. Once task 3, task 2 is over, again it gave opportunity to task 4. Again, still the number of threads at the moment is 3 again. So this is how it's going on, friends. This should give you a clear idea. What is that? With this thread pool executor, you can control the execution of threads in a much more efficient. You can see this. You don't need logs or you don't need to do anything. Everything is much more organized and controlled with thread pool executor. Right? You can choose how many worker threads you want and just submit those tasks to the this executor. Okay, and this takes control of everything, and the results will be written to this. And if you want to fetch results, just iterate that results as completed. Then automatically you can see that what the results on that task you are implementing. Right? If you run again, also you can see the same. You just three threads started. When three threads started, you can see the execution flow here. So once after task 2 completed, you can see again it took task 3. Of course, the other task 1 is also completed, task 0 completed at the same time here. See. Now it just took another one to the thread pool, task 3 and task 4. And meanwhile, those results, whatever that is there for on these three threads, are again written back at the same time. So this is how the execution of threads keep happening with the thread pool executor. So you can also test this, friends. Let me share this with you. So please test this. That should give you a clear idea. Understood now? Next after that, is this clear for everyone? Understood this one? This is idea about thread pool executor. Romani, I think this is the one you are asking, right?
Yes, sir.
So I hope this should give you some idea. If anything is there, we will work on that and customize that. Not a problem.
Sure,
Clear?
sir. Yes, sir.
Yeah, not a problem. We can customize it as well.
Sure,
And
sir.
again, one more important thing, friends. Here we are executing submit, right? Instead of submit, you can alternatively use map as well.
Hmm.
So what is this map here? Instead of manually collecting future objects, you can see here, right? What you can do? You can use executor.map to collect those. This is much more simplified than submit. See here, if you look at this code block and this code block, you can see so much of difference. What is that here? This looks a bit lengthy, but here this see when you say executor.map, just pass that thread method and then how many threads you want to create. Simple. To this map task, you should just pass what is that map method? Sorry, just pass number of threads you want to create and call that method on which you want to execute threads. That's all. Which is simple here. Map is more simple here. And here you have to collect each of that results and then put it into results. Here, this just simply gets all that in one with this map without much this thing. And here you don't need to say again as completed. See this, simply we can just iterate that results and print result. Right? This looks much more simpler, right? What you can do now, just replace this code here. Just do one thing. I'm just commenting it. If you want, you can uncomment and test that code. Commenting this code just only for your this thing. So what do? We just put this here. In the submit, we are replacing it with what is it? Replacing it with map method. Okay, so yeah, this should be fine. And finally, just make sure we'll put this properly. Yeah, fine. Now run this. Same thing. See, when you look at this code and this code, this is much more simpler for us. Okay, let's run this now. The execution will be almost same. Do no big change. You can see now. Tasks three tasks are started because our worker object is maximum workers we can have 3. So thread pool allowed for three threads to start first, and then task 1 completed, task 2. Meanwhile, because there is a room for 3 threads, again, it again accepted task 3. Meanwhile, the other threads might be running, but at a given time, always that thread pool maintains 3 threads. A pool of how many? 3. And that pool will be efficiently managed among all these threads. You got it, right? Especially when you are doing data, you can see in database, when you are working with database connectivity, there is database connection pool. If you have some idea, because definitely you will have this idea, right? That even that works in a similar fashion. Implicitly, that connects database connection pool also uses a threading scenario. You got it right, friends. Because you are into data engineering, you have that idea about database connection pool, and thread pool, thread executor pool is also something. Finally, this is the only thing is we just modified replace submit with map. This is much more simpler one. That range you don't need to iterate. Just pass that how many threads you want to create in the form of range method, and that method on which you want to apply a thread. And this results simply you get there and just iterate it and print it. That's all. You don't need to apply any other additional method or anything like how you do here as completed. So this is much more simpler scenario. Let me just share this code with you. Okay. We are trying to cover almost at every levels of threading, friends, from very basic of threads to a bit of advanced threading as well, so that you can choose something which you think you fits your day-to-day development activity in your data engineering. Okay, so that's overall about this one, friends. And finally, this is about thread pool executor. Okay, tomorrow there is one more process pool executor as well. Almost, of course, process pool is almost same as thread pool, but difference is thread pool executor is easy and efficient, and generally this is best fit when you are doing IO bound task. IO bound in sense, just now, like doing some kind of, you can see here. Okay, so what is it? Calling some APIs, file reading, database reads, writes. All this IO, these are all IO bound tasks. Input means there is some kind of read and write operations. When you're doing such kind of operations, thread pool executor is the best choice. Suppose if you want to do heavyweight calculations, like, a lot of calculations are involved. Simple, right? In such cases, process pool executor is something really useful, because when you have too many calculations, we need a heavy use of CPU. Okay. In such cases, process pool executor is required. Maybe I'll just put one example for this. Anyhow, we are done with almost this threading same concept. Tomorrow, we'll just we'll take some just few minutes to cover up remaining one more example, semaphore, and then jump to regular expressions. Okay. Maybe I'll just quickly go through that process pool as well, but we don't stuck here in threading because we did already 3 sessions on threading. Right. This should, and just only to show you difference between thread pool and process pool, I'll take one simple example. And then we also have an idea on semaphore. Semaphore is simple. Again, if you look at all this process, the approach is same. We have multiple threads, and how we are controlling threads to have a controlled access. It's same like synchronization. You got it right, but much more efficient controlled approach. That's all, friends. Okay, so that is for tomorrow. Okay, we'll try to also start another new topic, regular expressions. Okay, after that, then, but tomorrow I think Shiva sir, we have a full day training program starting from 9:30. We have a MongoDB scheduled training
Okay,
in
okay, sir.
office.
Okay.
So maybe we can do one thing, sir. This tomorrow's session we will do it on Saturday, sir. This week we'll for
Okay.
sure do that.
No problem. No problem, sir.
Okay, sir.
Yeah.
Yeah. Yeah, friends. So that is FYI. Thank you, sir. We'll stop here. We'll have our tomorrow session on Saturday. Tomorrow I should start very early to office, as we have full day in person training. It's not even online. So that's why I have to be there. Okay, friends, we'll stop here. Yeah.
Sir,